Hello student, now we'll see the calculation to generate the square wave using timer 0. In earlier lecture we have seen what are the resistors are associated with the timer 0 in SFRs. So we have to configure that resistors. So first resistor we have already seen T0 con and INT con. INT con from interrupt and T0 con is a timer 0 control resistor. The first step, select 16-bit mode or 8-bit mode in T0 con resistor format. In T0 con resistors, they are given 16-bit as well as 8-bit configuration. Load TMR0H then TMR0L with initial values. Calculate the count and load the value of that count into TMR0H and TMR0L. Both are 8-bit resistors. If you use a 16-bit timer, then we have to load the count 16-bit count into TMR0H and TMR0L. If we'll go for the 8-bit mode, then only TMR0 will be in picture and TMR0H is not used. Start timer by set TMR0 on bit from T0 con. Already I said that these SFRs are bit addressable, so single bit we can set or clear. If you want to start or enable the timer, we can set that particular timer 0 on bit. Then monitor TMROIF, it is from INT con bit. This bit is used whether the timer is overflow or not. If it is overflow, if this bit is TMR0IF is set, then this TMR0IF will set, then timer say it is overflow is there, the count is completed. The when TMR0IF is set, then it is overflow. The stop the timer, reset the flags and again load the count into these TMROH and TMROL. Now here T0 con resistor combination. If I choose timer 0 with 16-bit timer without prescaler, what are the bits we have to consider? The first condition is say it is 16-bit timer. 16-bit timer means what? This T0 8-bit will be 0. Without prescaler, that means you are bypassing prescaler. So use this 1 bit. Now you are using internal clock. We are using this is as a timer delay, so we have to use internal clock. So this bit also 0. Then we are not using external clock, so this bit is don't care condition or put 0. So what will be the count of T0 con? First is 0. Later on we'll set this to enable the timer. Earlier we have to keep as a 0. Then this we are using 16-bit, that's why it comes with a 0. Then we are using internal clock, so this bit is 0. It is increment low to high, so this one is 0. PSA we are bypassing the prescaler, that's why it comes with a 1 and the rest of the 0 0, otherwise it is don't care condition. Now T0 con count is 0 8. Now this number is a 0 8. This is a binary number of 8 and this is binary number of 0. If I choose timer 0 with 16-bit timer with prescaler 1:8. 1:8 means this one combination. So this 0 1 0 0 1 0. But I am using prescaler, so this one bit will be 0. This PSA will be 0. So your combination is, so T0 con will be count 0 2H. Here generate square wave with frequency 10 kHz using crystal frequency 8 MHz. We are using internal clock frequency, that your F oscillator will be 8 MHz divided by 4. So without prescaler, so no need of to divide one more number. So only 8 megahertz divided by 4. T oscillator, we know the relation between the time and the frequency, both are inversely proportional. So T oscillator is equal to 1 upon F oscillator, which comes the value 0.5 microsecond. The square wave we want 10 kilohertz. 10 kilohertz means your square wave will be like this. So total time is this, T on plus T off. So total time will be 1 upon total frequency is 100 microseconds. 100 microseconds. So T on is equal to, say total is half of this, because we are doing, we are generating square wave. So T on and T off will be, both will be equal. So T on is equal to T total divided by 2. So 100 microseconds divided by 2 is comes with 50 microseconds. So the count is T on divided by T oscillator is equal to 100. If you go for the 16-bit timer, so 16-bit timers gives the how much combination is 2 raised to 16. 2 raised to 16, that's why 65,536. So the total count, what we have calculated earlier, subtract this from 65,536, you will get decimal value. Convert into a hex value. So this lower 8 bit and upper 8 will be stored into the TMR0L and TMR0H respectively. Like TMR0 will hold the 9C and TMROH will hold the 55. If this 100 decimal value is earlier converted into hex value, the formula will be different. FFF FF minus count in hex plus 1. If you go for a timer 8 bit, then the how much combination will be there? 2 raised to 8 is equal to 256. So 256 minus 100 which give the decimal value 156, which convert into the hex value 9C. So only TMR0L will be in program and TMR0H just neglected. In hex value 256, the hex conversion is FF minus count plus 1. Here I have written program to generate 10 kilohertz square wave. So we have to define header file, void timer init void. Void mean trace D. What is mean by it? Trace D is each port has a 3 resistors. What are the 3 resistors? Which are already defined in SFRs: port, trace and latch. If I am talking about the port D, the trace D, LATD and port D. If you want to define port as an input or output, we have to use resistor SFR trace D. So we cannot directly out any data through the port. So we have to first latch that data into LAT resistors and then moves to the out or in. So use LAT. Here I have interface LED to see the combination of square wave or observe the port. I have to either attach oscilloscope or LED. So that means this port is assigned as output port. So to assign output port we use 00, that is clear. If I want to assign as an input, then it gives the 11, that means FF. Then we want continuous square wave generation, so I call for while. Then LATD is 00. LAT, now I have to send the data 00. I call a timer function, timer underscore init. This is a function. So here I called for function timers underscore init. Then LATD 0FF is a toggle. So here written subroutine for this function timers underscore init. What are the steps? First of all, whether it is 16-bit or 8-bit. It is 16-bit without prescaler, so the T0 count is 08. Then load this TMROH and TMROL with the count. So upper bit is FF and lower is 9C. Now turn on the timer 0. So as I said, it is bit addressable. Now T0 con bits dot TMRON, it is from your T0 con bit 1. Now and fourth steps I explained that we have to observe this TMR 0 IF from INT con bits whether it is overflow or not. If it is 0, then stop the timer and uh, clear the your interrupt flag. One example I have given, write C18 program to generate a frequency of 250 Hz on port B. That means we have to toggle this bit with 250 Hz using timer 0, 16-bit mode, no prescaler, crystal frequency 100 MHz. I have already calculated this value. You can also calculate with the reference. I'll show you. MPLAB, then go to project wizard. Which I see PIC18F458. Next, I'm using microchip C18 toolsuit, so C compiler, because I want to write the program in C. Now browse. Square wave with timer 0. Save. Next and finish. Then file, new. So in this window we have to write a program in C. So already I have written this program. I'll just copy paste. Now what we have to do, so this is in C, so we have to give extension as a C. So we have to give extension with C. Save. Now go to source file, right click on source file, right click on source file, add files, then this where we have square wave underscore timer 0, open it. Now build it. If it is built successful, okay, no error is there. Now go to debugger, select MPLAB sim. Now view simulator logic analyzer, where we can observe the on which pin we are toggling. It is port B, fourth pin. So here RB4, only I'll choose RB4, add, OK. Now start animation. See, it will show the what is happening behind your program. Now it's square wave. You can take a printout of this output. You can scale. Okay, take a printout of this, save as a PDF. This is your output. Thank you, student.